Good evening to you all. We are Group SWML23 from the Department of Networks at Makerere University. Our project is entitled A Semi-Supervised Transformer Architecture for African Moral Narrative Classification, Mitigating Quadratic Attention Costs, and OOV Token Fragmentation. My name is Amandi Shemati, and I'm presenting alongside Okoth Victor and Johanna Mahamat Abderasul. And our supervisor is Mr. Galiwango Marvin. Here is the roadmap for today's work. We shall begin with the background and introduction, walk through the related work and problem we are solving. Then we present our research questions, contribution, methodology, datasets, and experimental results. We will close with the conclusion and the known limitations. Africa has a century of old transmitting traditional moral knowledge through oral stories and proverbs and songs, what we have called a living library. However, as the AI systems have grown powerful in this knowledge that we have called the traditional knowledge is at risk of being lost or ignored. The current large language models like GPT and Llama are trained predominantly with Western data and lack the structured data of African moral frameworks. And our mission is to address this gap by building what we call a digital elder, a cultural condition AI that can preserve and adapt this narrative for modern learners. Looking at the state of field, the transformer-based models have impressive generative power, but they are not culturally grounded. Communities like the Masakani are doing great work on African language, but moral folklore specifically remains understudied. Research also shows that the general purpose LLMs can encode Western moral biases underrepresenting African worldview. Our work sits at the intersection of these gaps, contributing both curated datasets and modeling framework that respects cultural sovereignty. We face two problems. First one is on the domain side, and the second one is on the computational side. On the domain side, African knowledge exists mainly in oral forms and has not been structured or digitized. This creates a real risk of cultural loss in this digital age. On the computational side, we are working with noisy text sources, very few labeled example, and long documents with strained data transformer architecture. Together, these problems demand a purpose-built pipeline, one that can be structured and model this data. Our research is guided by 5 questions. The first one is, how do we turn messy, unstructured folklore text into a clean, AI-ready dataset? The second one is, what linguistic and thematic patterns can we discover through the exploratory analysis? The third one is, how well do low-labeled learning techniques can work when annotations are scarce? The fourth one is, which transformer model perform best for classifying moral categories? And the last one is, how does all this enable future cultural condition story generation? Each question maps directly to one of our 5 objectives, which I will elaborate as we are going through our results. Our contribution fall into 2 categories. The first one is on the research side, and the second one is the output side. On the research side, we have created a novel corpus built on reproducible pipeline and benchmarked strong transformer baseline. On the output side, we are delivering a concrete, reusable artifacts, a clean corpus, and an ADA with over 25 visualizations, a training notebook, and a methodological foundation for the next phase of this work. Our system architecture follows 3 layers. The first one, we have the data engineering, where we ingest the raw folklore text, normalize and clean them. Then we structure them into analysis ready data sets. The second one is analysis and learning. We run the ADA, we apply unsupervised topic modeling, and then move into low-level learning strategies. For example, weak supervision. And the third layer is the output layer, where we train the transformer model, specifically the XLM Roberta and the Deberta V3, and evaluate them on the moral narrative classification task, with the end goal of enabling the digital elder generation system. Thank you for listening. I will pass it to the next presenter.
Hello everyone, my name is Okoth Victor, and I'm continuing from where my other group mate stopped. So I'm going to be taking you through the dataset description and the exploratory data analysis. Here I'll be taking you through on how our data we made it, how the EDA was made, the visualization, such that you'll be able to understand our dataset very well. Our dataset, the dataset contains 17 text files collected from the African folk care, the traditional resources. This data format, it was unstructured raw text with heterogeneous styles and length. The initial schema in the notebook was we have the doc ID, the source file, the raw text. Then we had empty documents, very short stories which are less than 100 words. There were 0. We had no duplicate raw data. The noise indicators detected in raw corpus, the contents in 8 files, preference in 6 files, introduction in 12 files, a bibliography in 3 files, the projector Gutenberg in 1 file. So, cleaning removed structural artifacts while preserving core narrative content, low to moderate removal percentages across the files. Now, when we talk about the explanatory data analysis, which is our EDA, we are able to produce 25 plus visualizations across the lexio structure, the sentiment, and the thematic dimensions. The document length are highly heterogeneous, that is to say, the strong size, the imbalance across the sources. And then our lexio diversity varies from the source, indicating different narrative styles and repetitive levels. The frequent unigrams, the bigrams, and the trigrams reveal the recurring moral and the cultural motives. Then when you look at our correlation analysis, shows that the coherent relations among the size, the linguistic features, then the topic and the clustering views, where we will be looking at the k-means, the hierarchical SVD, then the relevant Latin thematic groupings. Then the corpus is complete and non-duplicated, but initially contained non-narrative structure noise. So after controlled cleaning and the dataset became ready for our analysis, revealed meaningful thematic and linguistic structure suitable for our low-level NLP modeling. When we continue to our output results and the discussions, the cleaning impact before, and when you look on our table here, you can see that before and after the table comprises of raw len words and clean len words for each line. Most files show low removal percentages, which means the pipeline did not aggressively delete narrative content. The removed part mainly corresponds to the structure noise, which is the extraction markers, the headers, the metadata fragments. So the cleaned corpus is safer for analysis and modeling. When you look at our table, all of this is, you can see it very well from the figures we did. Next, when you look at our results and discussions, here I'm talking about the visualizations we had. First of all, when you look at our distribution of word counts, you can see clearly we made a line graph which was incorporated with a bar graph. When you see clearly, we have a wide spread of document size with a right scale distribution. Then the box plot by the source confirms that some books are much more longer than others and contain outliers. This matters because longer files can bias future statistics and model behavior, so we interpret results with length imbalance in mind. Then when we look at our next visualization, the Lexio diversity distribution, here we can see that it's not uniform across documents. Some texts are vocabulary rich, others are more repetitive. What does this show? It shows strong links among the size features and weaker links within with the sentiments. This indicates that the narrative complexity is multidimensional, so we need multiple features to represent the corpus properly. When we continue and when you look at our correlation heat map here, you can clearly see few of the negative values are indeed in our data set. That shows our data set is clearly made clean. On to the next, we can clearly see that on looking at our SDV projection and the cluster size distribution. So for the SDV, it places documents in latent semantic space. Documents that are close are more similar in content. Then when you look at our k-means clusters, the combination suggests that the corpus has meaningful internal structure which supports unsupervised grouping before downstream supervision. So when you see the plottings in the graph, it can clearly show you that the clustering here across our data set, it is well distributed. Then when you look at also the bar graph, it shows how our data set supports unsupervised grouping before the downstream supervision. Thank you.
Good evening, everyone. I'm the last presenter. My name is Yohana Muhammad Abdurasul. In this slide, we show results from topic modeling using two methods, LDA and NMF. These head maps show how topics are distributed in different documents. We can see that many documents contain more than one topic. This means the story have mixed ideas like moral and cultural terms together. Also, both LDA and NMF give similar results. This increases our confidence that the topics we found are correct and meaningful. These results are useful for the next step, which is story generation. Here you have a conclusion and the limitation. In conclusion, we clean and organize African history text into a structured data set. Our data analysis showed clear patterns in language and terms. Using unsupervised learning, we found meaningful hidden topics in the data. We also tested low-level learning with a strong model like XLM Rubeta and Debeta. Overall, this project builds a strong base for creating a system to generate cultural stories called a digital elder. For the limitation, however, these are some limitations. First, the dataset is still small for deep learning. Second, the labels are not very strong and may contain errors. Also, class imbalance affects performance. Long tests are sometimes cut by transformers models. Finally, cultural meaning is not fully captured by simple rules. For the next step, we plan to increase the dataset with more African stories from different regions and languages. We will create a high-quality labeled dataset with expert validation. We will improve learning using better techniques like pseudo-labeling and active learning. We also want to test more advanced models like long format and bad topic. Next, we will build a system to generate culture-accurate moral stories. We will also include human evaluation to check quality. Finally, we will create a digital elder prototype for real-world testing. For the acknowledgement, we thank our course lecturer for the academic guidance, for the feedback and project direction. We also thank our teammates for their collaboration in data preparation. Thank you.